Let's keep on going with the process here. Identification and seizure. So figure out what the tools are, put them all together, take them away with, of course, your proper documentation to allow you to do that. Preservation, evidence bags, those kinds of things, that gets us where we're going. Recovery. What we're trying to do is we're trying to recover all of that evidence. And when we talk about recovery, what we're doing is we're looking at files that have been deleted or corrupted that we can resuscitate, if you will. Harvesting, pulling out that data for your particular, under the particular scope that is what you're evaluating. So make sure that you collect up all that data. Here's the thing in harvesting. Do you really need the data about the particular operating system files? You know, that this particular DLL or that particular DLL? In a lot of cases, the answer is no. Now, some pieces of it, like the registry, are very, very valuable places where data resides. But the general operating system executables, as long as they haven't changed in any way, shape, or form, they're really not valuable to this. So you can say, okay, I've tested to see that this operating system files, these are actually truly the files. I've done an MD5 hash against those files and compared it with a reference system from the original vendor on that particular operating system, and they are the same. So I'm not going to take them as part of my evidence. I'm going to set that aside. It's all that other data that is important to what's going on. That's the harvesting that you're looking at. And then once we have this big blob right here of harvested data, how do we reduce this down to what is relevant to the case at hand? Remember, in the scope, if we're looking for this particular activity and we see evidence of another activity, that's out of scope. That's not what the warrant was for, and we can set that aside and focus in on this. We do an organization and search. Putting these things together in the modern day, with the modern day tools, we actually do a case evidence log with lots and lots of bookmarking tools. It really gets us organized because remember, we're talking about thousands and thousands of files. We need to be very organized about that. And when we're talking about evidence, we're looking at, I would probably say, thousands and thousands of files on a computer, probably hundreds of files on your modern day smartphone. We're going to analyze all this data, we're going to report it, and then we're going to create persuasive testimony for presentation in court. When we talk about collection and securing the evidence, we're using bitstream copies. Bitstream copy is it's the formal name. What we usually say is we're imaging. The problem with the word imaging is, oh, are you taking a picture of me? Is that what you're talking about here? No, when we actually image the drive, we're taking a copy bit by bit and putting it into a file in a lot of cases. Let's talk about write protection along with that. So bitstream copies, bitstream image is the same thing. Actually, when you do the bitstream copy, you are copying bit by bit. When you deliver it to a particular drive, you're actually creating a bitstream image. So you do bit by bit, and it results in an image. Now, again, imaging is to create a forensic copy or make a bitstream data copy. Those are all synonyms that you're going to run into. From an exam standpoint, you need to know all those synonyms because they're going to try and confuse you a little bit. So know those synonyms for yourselves. How do we do imaging? How do we get this done? Up to this point, I've said image the drive, bitstream copy. Well, if you're on a Linux machine, you can use a command that's been built in for years. It's called the DD, which stands for disk duplication. You can use other specialized tools. The reason why you want to use DD is because it's portable among all different systems. By doing the DD, you're creating the raw image that you can work with, those raw files, at a bit-by-bit level, and that is suitable for any tool that you're working with. If you decided to use Encase, it actually has its own proprietary file structure that is not readable by every single tool out there. Now, most tools, by the way, most robust tools like FTK or SMART actually will read the Encase images, so they all read each other's. DD is the one that is universally acceptable. When you're doing this imaging, what you're looking for is a way to do it without changing the evidence. And the simple way to deal with that is through write blocking. We create a physical device between the source drive, which is the evidence, and the destination, which is the copy of the evidence. Remember, you got a reference set and one that you actually is your working copy. But when you transfer information from here to there, you put this physical device in the way to block data flying back up the stream. That allows you to say, I did not change the evidence. Here's the physical write blocker. You put it in place prior to the acquisition, and also you flow that data out. A lot of those devices have built into them the ability to generate hash values as they pass the data stream across there. So that makes it a little bit more elegant. What you do is, before you pull the reference drive, you pull out your hardware write blocker and you get it prepared. If you have a sophisticated machine where the write blocker is built into the disk duplication with the big Pelican case, that's a little bit different. It's all pre-programmed for you. You don't have to have a separate write blocker. Most of today's write blockers that we're dealing with come in two flavors. So we're talking about hard drives or we're talking about cell phones. So those are the two kinds that you deal with.